let us start with something that looks like this. So I want to do sine of, let us say, tan of x cube, okay, into secant square of x cube into x square dx. We want to integrate something that looks like this. Now, if you want to start by saying, oh, let's guess one quick function which differentiated will give us that, actually it's not that complex. Let us think. But before we get there, let us think about if I wanted you to differentiate tan of, let us say, sine of e power x square. What do we do when we do things like this? So what is the answer? Now we call this the differential of this big function. It is actually, you forget about this whole thing and you say it is tan of blob. And so you will write this as secant square blob, which basically is sine of e power x square into, now let's not do the next step. Let's not do the next step. Into d of blob. Correct? If you think about it, this is what it is. D of tan of something is secant square of that thing into d of this thing. Actually, this way the rule doesn't look very much different from saying d of tan x is secant square x dx. D of tan y, secant square y dy. D of tan blob is secant square blob d blob. That's actually the rule. Correct? I can then think of this way, this whole thing this way by saying secant square blob d blob. As long as this is also blob and that's also blob, the same thing. It could be xx, it could be yy, it could be x square, it could be sine of e power x square, sine of e power x square. We just don't care about this. Secant square blob d blob is d of tan blob. We have learned this as chain rule. Of course, we don't stop here and we go one more step. So what happens when we go one more step? This fellow gets split. This sign comes out because this sine blob. So what happens? This becomes cos e to the power of x square d of e to the power of x square. This only this part. So that means the whole thing has become secant square sine of e power x square cos of e power x square d e power x square. Now if I took this part, this alone if I took separately, this will become e to the power of x square d of x square. And if I took this separately, this will become 2x dx. And so this into this into this into this dx is the differentiation of that. This is what we did when we did chain rule. Okay, what do we want to do now? We want to basically pack things back. No problem. If I had a question that looked like this, so if I had integrate secant square sine of e to the power of x square into cos of e to the power of x square into e to the power of x square into 2x dx. Very easy. Take the 2x, put it inside the dx, it becomes dx square. E power x square dx square becomes d of e power x square. Cos of e power x square dx e power x square becomes d of sine. So basically let's take this and becomes d of sine of e power x square. Secant square blob d blob becomes, so this becomes integral d of tan of sine of e power x square, because when we took this, that was d of tan of sine of e power x square. And now the answer is that. So if the question came in this form, answer is very easy. But obviously people who give you questions are not idiots, no? They won't give it to you in this form. So they are going to give it to you in a slightly different form. So here is a reasonably easy form. But the principle is the same. What do? You can't, like when you're differentiating, what do? You pull out whatever you can. I don't know how to differentiate this. But do I know how to differentiate tan blob? With respect to blob, I do. What is it? Secant square blob. So first take the tan out. Then worry about the blob. Then this blob looks like sine of something. Don't worry about the something. Just focus on the sine. So take that out. Then worry about this. That's what we did for chain rule. In integration, we will do the reverse. So take one by one and push it inside. Push whatever you can inside. Then worry about the rest. So far everybody understood the basic principle, right? So what I am going to do now is to apply this basic principle to this question. So let's look at this question. First, let us look at this and say, well, look at this. This is x cube, x cube, x cube, x square. It will be nice if this fellow goes inside and becomes x cube. But unfortunately, if this fellow has to become x cube, when it comes out, it has to look like 3x square. Now don't do x cube by 3. I said that this formula you use only when it is separately hanging around. For this procedure, don't use that formula. Think of it this way. What do you want here? I want 3x square, so that what goes inside will become x cube. So what do you want? What is missing? 3. Put a 3. It's very easy. Whatever is missing, put whatever you feel like. You want 3, put 3. Except the question should not change. I is equal to, I don't want to change I. But generally if I multiply this by a 3, that's going to change the question. So I must divide by a 3. But you can take out constants. So take this 1 by 3 and move it all the way out of the integral so that it doesn't disturb us. Is the procedure clear? Now, why am I explaining it in so much detail? Because what you will find is knowing how to actually integrate is critical. Just for confidence. Not that it's going to be greatly useful immediately. But if you know how to integrate anything, generally it tells you, okay, this can be done. Then you will focus on the more important thing, which is the meaning. So it is important to know how to do this step by step, because the point is not to know how I solve it. The point is for you to be able to solve it. So each step is easy. So think of it that way. 3x square dx is what? dx cube. I am going to get rid of this thing and I am going to write it as dx cube. Is it? Think. Because right now I am going to erase and write this. Luckily for me, I can do that. Generally for you, when you write it with a pen, you will have to write it as next step. What is the great advantage in erasing? Because I don't have to write this big thing again. Okay, but there is an advantage in not erasing. Because you can quickly check. Okay, now that after I erase, you won't have the question. But so before that, let me look at this. dx cube, what is it? Because it's always in reverse, no? So think about it, 3x square dx, yes? Now, I am going to get rid of this 3x square dx and replace it by dx cube. Now, x cube is blob. I don't even want to look at this. With respect to x cube, this looks like secant square blob. Secant square blob d blob is d tan blob. Let's quickly check. What is this? D tan x cube is secant square x cube dx cube. Yes, you are sure? Okay, now I am going to push this inside the d, and what will it become? D tan x cube. Do you understand what we are doing? We are actually pushing everything into the d. So let us get rid of this. It has become this. Of course, I don't like it there, so let's put it up there. The same thing. Now this has become blob. What is that? Sine of blob. But sine of blob is a little messy. No? What formula do we know? Look at this. D cos comes out as minus sine. Doesn't come out as sine. D sine comes out as cos. Do you think it would have been a D sine? Because D sine won't come out as sine. So what do I want? I want a minus sign here. Now always when you are doing integration, always make the adjustment before you push it inside. Don't make the adjustment after. Don't take it inside with a minus sign, because as it is you are remembering a formula in reverse. It gets very complex for you to remember. Sin x dx is minus d of minus cos x, and then differentiate minus cos x is minus sin. It's too much stuff. Remember one formula. Trust me, it makes a difference. Because memory is a very fickle thing. It's going to be a mess. You are going to remember many things. Unnecessarily remembering things with too many minuses is a pain, because finally in the exam, it will land up in trouble. So if you clearly remember once and for all, cos minus sine, that's it. What do I want here for it to look like that formula? I want a minus, put it in now. Don't take it inside and put a minus. Before you take it inside, put a minus. But for a minus, you must do a correction, which is to put one more minus. Because minus minus is plus. But the second minus, I'll take it outside and put it there. Because minus is just minus 1, so it can go outside. Now this looks like minus sine blob d blob. This is d cos of tan of x cube. Is it? Let's think. Always when you are doing this way of doing this integration, you are going to save both a lot of time and a lot of steps. So therefore spend some of that steps that you have saved in checking every point. Check. D cos. What was the formula for cos? Co means minus. So minus sine blob d blob. Does it work? Okay. So now this whole thing has become that. The integral must come as it is. The minus 1 by 3 must come as it is. So the integral is this. So now we have finally got integral and d next to each other. Done. Cancel. So that's the answer. And we forgot something. Plus c. Because when you do that removal, add a c. Clear?